Hey, how you doing there, Ben?
Hey,
What's up,
everybody.
Chris?
Good. How are you?
Oh, hanging in there
That's
on a
good.
Wednesday.
Hey, Lisa. It's been years. How you doing?
I know, doing all right. How are you, Ben?
Good. Good. I saw this and I'm
Mm,
excited to see what you guys got going on these days.
Okay, we're excited to show you.
You know us, man. We're up to no good. Moving packages.
Good. Good.
What's up, Chris? Been a minute, man. Have you guys been staying busy over there in Miamisburg?
Yeah, we have been
Nice.
get our expansion opening up.
That's
Uh,
right.
Wall has its pass throughs and everything in there looks. We're moving projects out there, get some stuff deployed. Be a while till we have it fully utilized, but kind of
Yep.
let that fill out organically.
Yep. Yeah, you guys were definitely in
Nice.
need of that.
Yeah, we've been ready.
Yeah, been ready for some years.
When's uh when's the expected open date?
Uh, so we have our official um, lunch opening it in is that August 10th, I think.
Oh, just around the corner.
Okay.
Yeah, I mean it's open functionally now. We're moving stuff out there.
Yeah.
Uh, Construction's complete.
Nice, man. Well, congrats on that. In case anyone's wondering what we're talking about, it's Yaskawa's expanding the headquarters there in Ohio, making some more room for all these robots. All right, we're almost to that time, and I do have quite a few slides I'm going to try to get through here in the next 30 minutes. We will see. I will be expediting them as fast as I can.
Yeah, we were thinking maybe this one should have been a 45 minutes, but we'll see. We're gonna try and do it in a half hour. If we go a few minutes over, heads up, guys.
Yeah, right.
I'll forgive you.
Ah, thank you. And I like your
You'll get the
idea, Chris.
recording if you gotta leave early.
Me and you should team up on something. That might be pretty fun.
Yeah, I absolutely.
All right, it's 11 o'clock. Let's go ahead and get started. Thanks for joining us for the second installment of our Get a Grip webinar today as we dive deeper into PickOne. Today, Alex Berry will take you through PickOne, our AI and 3D vision software, discuss how it works, why it makes the decisions it does, and the limitations of vision software. My name is Lisa O'Brien, and I'll be moderating today's session. So a few quick notes before we get started. We'd like this webinar experience to be more conversational, so feel free to turn your cameras on. We want to get to know you, right? If you have a question, you can raise your hand and we'll call on you to ask it, or you can put it in the chat. If we don't answer a question during the presentation, we can address them at the end too. Also, lastly, today's presentation is being recorded, so a follow-up email to everyone with a link you'll get the recording in a link, in an email with a link. So before we dive in, I'd like to welcome Alex Berry, who's going to be presenting. And I'm going to go ahead and allow him to introduce himself. So Alex, over to you.
Awesome. Thanks, Lisa. We'll go ahead and jump in. And sorry if I'm a bit nasally. We have this Saharan dust problem in Texas right now, and apparently my body does not like it. But anyway, my name's Alex Berry. I'm an application engineer here at Plus One Robotics. I've been here for about 3 years. Built a lot of demos. I built demos with partners at trade shows, as well as done site audits, automation audits, technical fits, and worked with a variety of our end users and partners. So I have a pretty unique perspective between the engineering and sales stuff. You can see a little bit of my background here and the icebreaker for this one today. Feel free to jump in and yell or put in the chat. But if you can guess what I'm doing right here in this picture, and if you did your homework, I didn't know we didn't tell you you had homework, and you read my bio, it's probably going to be pretty easy to guess. But I'm building a demo, which is what I spend a lot of time doing. This was actually back in 2022 at Modex, so This was my first big trade show I built a demo for, and I really enjoy that part. All right, so the agenda. I've got a lot of things to go through and a little bit of time. So we'll try to get it all knocked out and get you guys back into your day. First, we'll start about what's in the box. So what do you get when you cut us a PO? What are you going to get from us? We'll go a little deeper into how PickOne operates. Some of this will be a refresher from the first one, as well as how do you commission PickOne? So what tools do we have to support our partners and our end users in interfacing with our vision technology? Then we'll take a little more technical dive just into AI and 3D. I like to call it knowledge and understanding. We'll be PickOne centric, our AI vision software PickOne, but it will also be as a general overview to AI and 3D. We'll talk about features and benefits of our technology, and then I'll rain on everyone's parade and tell you all the things computer vision can't do, and then we'll try to recap on everything that we hopefully learned. So what's in the box? When you give us a check, what do we give you? We're going to send you an industrial PC, which is configured and custom manufactured for us with the specific hardware and BIOS settings and things like that to work with our software. Then you'll get our actual software loaded on there, configured for your application. So whether that be in depal or parcel induction, you'll get sensors, which a lot of people will just call them cameras. You could have one, you could have two, you could have a lot. Again, all depends on the configuration of what you ordered. You'll get computer vision specific lights, which are different than just, like this light that's shining on me right now, or, lights that are lighting your building. There are some technical, capabilities and quality control metrics in place for those, as well as cables. And this may sound a bit, like nothing, but the cables are very important, right? There's a lot of data passing to and from the sensor to our software. We need it to be fast. We need it to be reliable. So you do get specific cables that are approved from us. A calibration target, which is to calibrate the vision system and the robot together, as well as some other, knickknacks and things like that. And for people that are not familiar, most computer vision lights are going to be in a bar form like this. I have kind of, some banner picture on the left and some smart vision stuff on the right. But as you can see, they're all diffuse, right? This is one of the bigger points of computer vision lights. They also have the, a very specific color. So the kelvins and a very specific lumens that they operate in. And it's for consistency. It's to eliminate shadows, have extremely consistent lighting of the area so that you have consistent results. I wouldn't say better or worse, but predictability is critical in any type of automation. So how does PickOne operate? 2 steps. Step 1, hardware. So this is all the stuff that we don't make. This is all the stuff that other companies make, like Intel makes our sensors, Advantech and OnLogic make IPCs. There's other people that make cables and stuff like that. We run on Linux, on the operating system Ubuntu, which is, if you're not familiar with it, I mean, Linux is extremely prolific operating system, and Ubuntu is very specific in the computer vision space, right? It's been kind of the go-to and de facto operating system for a long time. Inside the IPC is a GPU. If you're keep up with that, like NVIDIA stocks, I know they're making a lot of news and stuff lately. Around 2016 is when the hardware of the GPUs really allowed the technology that we use in computer vision and AI to actually like do meaningful work. And what I mean by saying that is, say, circa 2008, you could have the same software, but it's going to take you 2 minutes, to get a pick. Well, that's not really useful for anybody, right? I mean, people pick these things in a second and a half. So through the development of the hardware, we were able to use our software in a way that was, doing work at an operational level. We use 2 different sensor types. Again, don't make them. We use a stereo depth camera for parcel induction, and we use a LiDAR camera for depal. These sensors are chosen because of the area in which they work, and mostly it's range. Stereo cameras have a limited range. They have their pros and cons. And LiDAR, though, has a bigger range, even to the extent of like self-driving cars where you're looking, 100 meters ahead. A harp on the cables again, because the cables are really important. And I can't stress it enough. If you go to Best Buy and you just buy yourself a USB cable because you have a PickOne system and somebody ran into it with a forklift or something like that, you say, "Oh, I'll just buy this USB cable." you'll just get unpredictable results. I'm not going to say it will or it won't work. It's just unpredictable. And any type of automation, you want predictability. And lastly, the part of the hardware that really, keeps predictability and consistency is the lighting. Our lights are designed when we do our layouts, we work with our partners to be the dominant light source. We want it to be a situation where you can have all the lights on in the warehouse or none of the lights on in the warehouse, and you will not get different performance out of our vision system. Eliminate shadows, and just consistently provide the same kind of color picture back to the vision system. Step 2 is what we do make, right? Our software architecture. The whole point of our software is to give you the most pickable item. And that's kind of maybe a phrase that we made up in here, but it's not just what can you pick, but what is the best thing to pick and in which order should you go about picking those things. So in depal, like in this picture that I have here, this item down here is the closest one to the place zone. So if we're capable of picking it, I mean, I could tell you the order of which pick one. It'll pick this one, that one, this one, that one, then this tall one. Obviously, some other stuff will come up in there, but the order in which you pick them is extremely important. That's our pickable deal, right? The This will breed in a little bit. There'll be quite a bit of me talking about the same thing because of the interconnectedness of the topics. But we use 2 data streams. The first one will be 2D, right? Just the RGB image, just a picture, kind of exactly what you're seeing there on the right side. That's what the AI is going to use, right? It's going to look at that and say, this is a bag and this is where it exists in the world and these are the edges of it. And our AI is designed to look at things that you could pick. And then you have the 3D data, which is like a representation of the real world. Where things physically exist in the world, the angles that they're at, the textures that they are, and that's the information in which you could generate a pick point off because it has height, it has physical is located in the physical world, so it can actually develop a pick point. Whereas the 2D image that the AI is looking at is just a flat image. We also use the 3D to understand, if the gripper is going to collide into something, other physically dependent tasks. So now you see, kind of all the things the software can do. How do you even use it, right? How do you set it up? Fortunately for all you guys, we made a really nice GUI system so that you don't have to be a computer vision expert to use the technology. So it's good for everybody. You don't live in the command line. And if anyone knows what it is, you don't want to live there. So our GUI is called PickOne Assistant, which I think is a pretty good name because it assists you in setting things up. You can commission systems and you can tune some of the higher level parameters to get the, say, behavior you would like to get out of the system. For the sake of brevity on here, I won't go through like the whole list of all the stuff you can do in here, but I do want to hit kind of the 3 big points that are bolded there. Calibration, background image and data, and these bounding filter yonder box. I think these are important because every time you deploy, you're going to need to go through these steps. Whether it's a replicate or a rollout at scale, you'll still have to do these 3 steps. Most of the other stuff will be filled out and populated in the software, and it will just be ready to go. But these 3 you'll have to do every time. So the first one is in the calibration, right? The calibration is going to use a target to tell the vision system where 0, 0, 0 is, what direction X is in and which direction Y is in. Then you would calibrate the robot to the same frame, or vice versa. Calibrate a robot and then put the calibration target down for the vision system. But the key here is that the vision system knows where the origin and the X and Y are. That's the same as the robot. So that when it gives the information back to the robot, they're looking at the world and operating in the same, world, so to say. The next one is the background. And I've got image and data there because they're 2, again, input streams. The best way I can describe it is if you pick up the robot cell, whether it's a depal cell or an induction cell, and you just like shook it, and everything that fell out, and everything else was still there, put it back down. That's the background you want. Those pieces of equipment that are never going to change and they're always going to be there. Guards, conveyors, things like that. That's what you want to have in the background data because our software is going to use that to understand what changes in the world and to be more optimal in what data it actually decides to analyze and to make a decision based out of. So you're not having to analyze data that is irrelevant, so to speak. And then lastly is the boxes, right? Defining the bounding box, the filter box, and the yonder box. We'll talk about the first two because the third one's a little bit different and specific to, +1. Bounding box is essentially the area in which you're going to tell the robot or you're going to tell the vision system it's allowed to give the robot a pick point as long as the pick point is within this box, right? It's a volume, right? Of there. If it's in here, you can go pick it. So essentially, this is going to be where can the robot physically reach. We'll get back into that point a little later on with limits. So you're going to define that area. Then you're going to define a filter box, which have there in the notes. It's going to be a little larger. And this is the area in which you're telling PickOne, I need you to, analyze all the information in this visual or in this cube, right? Visually analyze every bit of data in here. And the yonder box is the one for our human in the loop software yonder. And it's its own separate area. A lot of times it's about the size of the filter box because we need to give it a bigger area to look at and a bigger area to work in because the likelihood is that the system had something going on that it couldn't solve autonomously. And if we're going to have a human in the loop to come solve the problem, we're going to need to give them that flexibility to do what's required to have the robot go solve the problem, get back to autonomous picking, and not, have to constantly have, people on the floor come over and help because they don't have, our crew chiefs don't have the tools that they need. As well as the last bullet point. You can look at logs, you can look at statistics, you can watch live camera feeds, things like that on this GUI.
Alex,
Yes.
go back a slide, please.
Yes,
So
sir.
what takes priority when one of your remote crew chiefs are looking at this, even though possibly the yonder box is bigger than the bounding box?
Mhm.
Are they allowed to specify a pick location outside the bounding box?
Yes. So a crew chief would be able to specify a pick location outside the bounding box. Then, so if you look back onto it, kind of, in our, approach to this problem is to be, an enabling technology to a traditional piece of hard automation, to a robot, to array sensors, vacuum sensors, force sensors, the whole gambit of technology that already existed and has been used in industry for, decades. Obviously, Yaskawa's been doing, layer picking and depal for a long time. We want to allow them to have the flexibility to make a command, send it back in, and it could be rejected, right? Like the robot say, yeah, you sent me somewhere out of the zone. I'm not going to take it. I'm going to go. Now, that's definitely the weird edge case. We don't generally configure systems where the crew chief could send the robot somewhere it can't reach. The more likely scenario is they deep house the easiest example. The bounding box will be some very small dimensions larger than the pallet. A little bit customer specific on how they do their pallets. But basically, you'll have a few inches around the pallet that says you can autonomously send the robot to any of this area. But what if something falls off a pallet? Right? At that point, you want to have the yonder box larger than that, still within the robot reach. It's still somewhere safe to send the robot, potentially safe, but you want a person to verify. Like, should I actually send the robot to go pick up this item that fell off? Well, if they're not allowed to go outside of the bounding box, then they wouldn't be able to send it to fix it. That's generally more of the case that exists in the real world versus having a yonder box that's larger than the robot could reach. But you'd still
Yeah.
have those kind of controls checks in place. So good
Thank you.
question though. So AI in 3D. We'll start with 3D. As I had said earlier, I kind of consider this the understanding, right? I understand what the real world is. It's not exactly the real world. It's a measurement or a representation of that, but it's an understanding. And there's three kind of forms of that. Two of our sensors that we use are of all three form. The stereo camera is also using structured light. You can read in there specifically how it's done, but it calculates depth. And then LiDAR, which you see on the bottom. So one of the points I point out in this picture, and we'll see a visualization later on for our visual learners, is both of these sensors and both of these packages, the sensors are beside each other, directly above this package. But since they created a 3D world, we can manipulate around in there and look around, which is just something I think is really cool. But I wanted to note that out because they are looking from one perspective, right on top of this package, which we'll get into the limits of computer vision shortly. And the last point in here, and this is more of a, a testament to, our development team and our technology. In order to take 3D data and to process it, you need to take it through subframes over time, right? Just like a movie is 24 or 30 frames per second, you might grab 4 or 6 of those, however you want to slice up your software to pull it, and then you're going to need to do something because they're going to be just like this red and black line on the bottom. Some of the points, if you imagine this is like, say, this corner of this package right here. And these are the points in the point cloud. And the black one is frame 1 and the red one is frame 2. Well, you have differences in there. That could be a millimeter, it could be a half a millimeter, it could be 10 millimeters, whatever number you want to put in there for your math. Your software needs to be robust enough to understand how to handle that. It's not something that's as trivial as it may sound. Oh, just take an average across there. There's actually a lot more complex kind of algorithms that go into deciding what to do with that point cloud data in order to normalize it and to make it representative of the real world. And I only say that again because I think our software does an excellent job at this. And then here's a visualization for all you guys that like to learn visually. This is where I only have one LiDAR camera directly above this pallet, which is only about 2 feet tall. So I'm quite a ways above it. This camera's about 14 feet in the air. And again, that's the point cloud, but you can see how it's only across the top layer. Right as I go down to the side, you just have this, looks like a shadow, but it's not. It's just there's no data there because I'm just directly above the center of this palette. Obviously, the RGB is already overlaid in there. But for people who haven't seen a point cloud, haven't seen how 3D vision looks and how it works, I think this could be, something that you can really understand. You can see all the extra stuff I see in there too, like the frames of the sail, and I see like the alignment justification, metal for the palette and things like that, which is why we have the bounding box, the filter box, and things. There's certain the background, there's certain bits of information you don't need to analyze every time. Doing on time, not doing too bad. Now we get into what I call knowledge. And I see a question come up in there. Let's check it out. So is Lucas. What you got, Lucas? How does
Yeah,
the
how does
picking order impact robot cell? Yeah, that's a great question.
because
It
like we see, specifically on mixed case palettes, like, you're gonna have some maybe big items or some small items. Um, how does that order
yeah,
does it matter?
yes, it does matter. I think you guys can see this laser. Yeah, it looks like it. So in this demo that I built, and this is, I would say, 90% true across all customers. Although we do a lot of simulations in house with our vision technology and in a 3D representative space with the robot and the layout and stuff on visual components. And generally speaking, though, on a DPAL, my place conveyor is right here.
Mm-hmm.
So our vision system is score based, and I'll get into that later. But it's going to pick this item, that item, this item, yada yada yada, all the way back. Picking the closest thing to the place location on a DPAL is very important for quality and for throughput. And it's certainly more of a quality thing because you don't want to continue to pick things up from the far corner, have to lift them all the way over the whole pallet and then move it all the way back over here. I mean, you could get it right 99 times, but the one time that you don't get it right, you're knocking the whole pallet over, right? So on DPAL, it's certainly more of a risk avoidance strategy, right, to do less risky things. On partial induction, it's a little bit different, right? You're not so, you know, critically important to pick the top layer, say, or the highest item that's in the pile, as much as you are wanting to pick the closest thing to the place zone along the path that the robot travels, right? Especially a wall-mounted robot's going to move in an arc. We have configuration tools available in PickOne Assistant, as well as like on the back end to create, scoring based on where something physically exists in the world. So it's not just an AI driven, whatever the AI thinks is the most confident about, but it's also part of the score is also in physically where it depends or where it exists in the world. To your point on how does that impact rate, if you in induction, if you always pick the easiest thing that's the closest, as the pile gets less things in it, then everything inherently gets easier, which means you make less mistakes, which means you spend less time either rejecting or recovering mistakes. Thus, quality and throughput improve by first pass yield. I think it's probably the easiest way to say that. That feel like a good answer to your question, Lucas?
Yep.
Cool. All right, so artificial intelligence is the knowledge. If 3D is the understanding because it's a representative of the real world, then artificial intelligence is the knowledge, right? What is the thing? So I've got some notes in here, so I'll make sure I stay on track with it. Don't share a bunch of secret sauce out here into the into the world at large. Um, I'm sure you guys are familiar with AI, at least in the sense of Chat GPT and again all the news around that. I mean, AI is such a broad field. Our AI, our model, our architecture is created to understand what's pickable and what an item is. There are some other things, those are kind of the two ones. What is a pickable item versus a non-pickable item? And if it's pickable, what kind of item is it? So that can be in classifications like I have there. Is this a poly bag or is it a pallet, right? Is this a slip sheet or is it a box, right? Understanding that and knowing that is a type of data that can be used on the system side to make a better decision, to be smarter because you're knowledgeable. It's not something 3D can do. 3D doesn't necessarily know that it's a flat piece of mail or a box, or that it's a partial slip sheet versus, a box. Um, or a pallet versus just an item that's long and cylindrical and layered up on a pallet. So these classifications allow the system to make a better decision. I think the the most drastic difference I see in how a system operates, especially in induction, is going to be on polybag classifications. When the AI says, yeah, this is a polybag, and we can compare it to dimensions and where it's located in the pick zone and things like that, and you're going to go pick it. Our systems are going to change the acceleration, the deceleration. They're going to change vacuum thresholds. They're going to change dwell time on the pick. They're going to change all of these factors about how the machine operates because the knowledge that it's a polybag versus the knowledge that it's a box. We'll do different things with the system based on the work that we're currently going to be doing. And I like this picture here. This is again from a debug image, so it's a little funny, but if you notice, you'll see a lot of things in there where you can see the bottle caps of stuff that's not on the top layer that you can see, and it's not, the AI recognizes that that's a thing, and it's not pickable because of these other reasons. So that AI's knowledge there is kind of that first pass, that first filter. What is AI deciding is pickable, and what is the thing? Um, as I get down here to the bottom bullet points, we'll go through kind of the operation of that. So since the AI has the knowledge of what the thing is, where it exists in the world, as far as the 2D image, that is then passed through in parallel with the 3D data that's already been kind of parsed and dealt with and normalized. And from there, we'll compare AI's predictions into 3D. And then that segmentation is then checked against the parameters in which how the configuration set up, which again, most of it's already done by us because we picked so many items. We know how to configure the software and help you guys out. Then it gets scored based off of a lot of criteria. And then that best score is given the pick point to the robot, which in DeepL could be multiple items, and it will tell you it's multiple items, 2 or 3 items. In parcel induction, it's always just going to be the one item. But that's how that is all processed through there. So
Real quick, Alex, just to
Yes.
point out, we got 5 minutes
5
left. Okay.
I'm turning and burning. Hi, Michaela, what's up? I see you got a question.
Yeah, real quick. So I get a lot of questions at trade shows of like, what makes Plus One stand out from the other competitors. So what would be your answer to that question?
Oh, perfect setup. Thank you. We're about to jump straight into that. So I'll let my slides speak for that question, but that I'll be happy to answer that. And I see Mr. Gupta up there. How does the gripper capabilities take into account when deciding pickability? There is knowledge of the gripper that you can input in there, the size of it and things like that, and those decisions are made. We'll see some of the features of that later on in the other slides. All I'm showing here is just another view inside of our PickOne Assistant GUI, so you can see how the system's operating, what it sees, what decision it's making. You can look at other metadata that's in there, and especially when you're commissioning or you run into a problem, you can use this as a debugging tool to understand it. You can run it with the robot running. You can just make triggers from the top to just see how the vision's going, and then manually remove items, while you're commissioning or you're setting things up. Again, my visual learners out here, that's me. I'll learn a lot more from this than reading. Okay, I've got a few minutes left. So features and benefits. We've been over quite a bit of the same topic, so I'll go through this rather quickly. Classifications, I've kind of been over why they're so important. You'll see in this specific demo of our Induct 1 with our individual cup controlled gripper that the gripper is actually changing what cups it uses based on how the vision system is telling it to orient the tool and which cups to use to put only the cups that are going to have vacuum on the item in which to be picked. Um, Angle manipulation for tilted parcels, this will get into towards the end, especially since I'm running into the time wall. Alignment of the gripper to the parcel, which facilitates in smart placement. Collision avoidance, so we don't send the robot to go crash into something to go pick something else. Oversized and undersized rejection automatically from the vision system, so you don't waste time, handling items that are too big or too small to be inducted. Um, the verification, did you do good work after you place the item? And then from there, how do you want to deal with it? And if you want to go back and send the robot to go fix the problem, like if you put 2 items, which I took this clip specifically for that because robot 2 keeps picking double items in this run, to go fix it, right? Go fix the problem. And the last one is specific to induction to motion detection. I mean, it's partly used in depal too, but specifically in parcel induction, things topple around and fall a lot. So you don't need to be trying to pick something that's in motion. You should recognize that, throw that data out, and get new data. And then intangibly, right? We've had over I think 1.2 billion parcels picked now. So we've got a lot of experience in how to do this in the most effective way for an operations team. Again, running the wall. Depal features. The biggest one, I guess, to point on here is that in Depal, you only ever need to pick the thing that's on the top layer. Right now, it could be multiple things that are kind of in a threshold, but you never need to pick something that's underneath something else because you don't know if it's underneath it, like on a lip, and you're just going to knock a bunch of items off. So our vision system handles that from nothing you need to do on control side, right? Like the vision system recognizes that, understands it, and will not give you an item that's under another item. Palette classification, slip sheets, and not all these great slip sheets that I get to use in my demo, which are beautiful brand new pieces of full-size cardboard, but a wide variety of colors and sizes. Multi-pack recognition, we call grocery items, understanding that this pack of ramens, it's not 6 ramens. I'm only picking up 2 ramens because they're 3 packs. I understand their height. Lastly, technically speaking, on technical value there, we can handle 8-foot tall pallets, and even in an 8-foot tall pallet, we can still analyze to a level of resolution to be able to pick a 6 by 6 by 2 inch item at the bottom of the pallet. And lastly, flexibility for our partners. You can have multiple pick zones, multiple place zones, all running through the same IPC so that your design and layouts are more flexible. And I'm at the time, so if you guys got to drop, I understand. But the benefits of PickOne, this is outside of either application, right? We increase your entitlement and your productivity because our software is fast, because we can make the robot capable of dealing with the real world in real time. Every time something changes, we take a new picture, we make another decision based on that. We have so many picks under our belt now and such a huge image library that we've trained on that I can't imagine a scenario, and I haven't been on a conversation in the last year and a half where we don't have an AI model, that our general model that doesn't already do 98% of what you're trying to send to the robot. There are specific cases, again, and we're constantly improving it, which is what you see over here as a regression test. But it's ready to go. I think a benefit is that we don't control the robot, that we're a piece of equipment that you add on to enable the technology to do something that was previously impossible. So we complement, our integrator partners, and we complement, sensors and robots, that have been out there in industry for years and work very well together with hard automation. Very easy to set up. It's a camera, it's cables, it's lights, it's a computer. It's not a lot to it. Obviously, our GUI, I think, is a really great tool because, you don't need to be a computer vision expert to get, just like you don't have to be a barcode scanning expert to use a Cognex or Keyence or Data Logic or SIG barcode scanner. They have a setup for it and it makes it easy. And that we're score based. We're not reliant on the AI, knowledge to, to be successful. We understand that the real world is where we're operating in, not the computer vision world, and we're trying to enable the technology to do good work. We're fast. We have human in the loop. The same points everyone else makes, right? We promote team members to higher value roles because we take this DDD, right? The DDD jobs, and as well as they could become crew chiefs, right? Customers can crew chief their own systems. And then our simulations and, what you see here, our vision analysis tools and stuff. So we're there to understand how our technology is really working in the real world to support, our customers. And lastly, to rain on everyone's parade, computer vision is inherently line of sight, right? It's not X-ray vision. It's not superhuman. You see there's an orange segmentation. There's a big cube put on there, which is essentially, say, a representation of the gripper where we're going to send it to go pick it, but we don't know what's under that. We don't know what's under that package or that DHL package that's there, that flyer, right? We don't know if there's something under there because my camera is just directly above it. So just in general, that was an approach that we have internally at Plus One, is that we provide a lot of enabling technology, but vision doesn't know everything that's going on in the system, and it only knows what it can see. The rest of it is pretty straightforward. Points I've talked about. Lighting affects performance. I don't like to say it makes it better or worse, but it changes the behavior. And everything's a compromise, right? If you have black items, you can tune vision to work on that, and then it won't work for white items. Again, through our experience, we have parameters that are set that work across a wide variety, but it's always still a compromise. Back to the 3D data, right? 3D data doesn't know that that's a polybag or if it's a big pile of stuff. It doesn't know that, but the RGB that the AI is analyzing is not real. So you need the combination of those two. You're still limited by what the AI knows, what it doesn't know, right? And the point I was making earlier, right? You can see things that you can't act upon. You can see things that the robot can't reach, or you can give pick points to a robot that are unreachable, that are in a configuration that the robot has no physical capability of achieving. So you need to be able to understand what those are, how the system can operate and how it's laid out, and only be able to give back points to the robot that it could actually do work on. We've been through kind of how we do that. And then lastly is just, again, the point of we believe that it supports smart automation, right? It's not, you don't put a vision system on and walk away and think, oh, this AI's got it all figured out. It's just going to work great all the time. We still work, in tandem with PLCs and robot controllers to, make the most effective and efficient systems out there that do the work in an intelligent way. Now that's what everybody's thinking, especially when I run through here super fast. I was talking about our applications, right? Parcel, induction, and depal. This is a nice picture of a super advanced warehouse with ASRS and the whole system, kind of where we fit in the warehouses, right on the more front end side, the inbounding side. And then recapping it from where we started, you give us a check, we're going to give you some hardware and some software. Our software is developed, PickOne is developed to give you a pick point of the most pickable item, right? To give you a score. We have a GUI to make it easy for our partners and our end users to interact with our software and to set it up. Obviously, 3D and AI, they're just each pieces of it, and they have to work together in order to do the job. And all of our features and everything that I talked about that was developed there under features and benefit is 100% feedback from customers. We've been at this for almost 10 years now, and we put stuff in there, and they say, well, that's great, but wouldn't it be good if it did this too? What would it take to be able to do it this way, right? And that's why you see different features developed for each one of the solutions or each one of the applications. And lastly, I hope everyone takes away from this that if someone tells you that all you need to do is add a vision system and this thing's going to be amazing and do all this stuff, they're not telling you the truth, right? It's not a magic wand. It's a piece of technology. It enables, systems to be smarter, but it's not the magic wand you wave at a robot and now your problem's, gone. So I don't know if everybody's asleep yet because I rolled through that one quick. Pass
There
it back
was
to you, Lisa.
someone had their hand raised a while ago. I don't know
Sorry
if
about
your question was answered, but that's all right.
Hopefully I answered Michaela's question on the differentiating features. Might not have dived
Okay.
deep enough into it, but
All right. All right. Well, if there are any questions that come up, please feel free to reach out to either one of us. This is our next webinar. Please sign up if you enjoyed today's. And also, again, if you want to talk about an opportunity with a potential partner or just, learn more about our tech, again, reach out to either Alex or myself, and we'd be happy to meet with you. So
Alex, I have a
think
question.
that is it.
yes, sir, Roger.
How are you doing? Good presentation. Thank you.
Thank you.
So when we talked about software, right? So there's hardware and software and lighting and cables. On the software side, for instance, if the integration partner and or Yaskawa want your software. Do you have a specific Yaskawa driver that you include in that, or how is that managed?
Yes. We have a few APIs developed for some of the common brands, Yaskawa being one of them. So if you're an integrator partner or an end user that's integrating yourself or however that may be, we'll supply the vision tech and we'll say, here's the programs to load right onto your Yaskawa. And we have boilerplates that obviously we worked on with you guys that are, here's a pick and place routine, here's a depal routine with, all of the type of controls, architecture and stuff in place. So if you're not necessarily have all the capabilities in house to do that, or you don't want to spend, 12 weeks developing it, we do have it ready to rock and roll.
Awesome. Thank you very much.
Got it, Roger. Thank you. All right. If that's everything,
All right.
then I'm out of here, guys.
Thank you.
You have a great day.
Thanks so much for your time, everyone. Bye.
Thanks, guys.
Enjoy
Thank
the
you.
rest of
Thank
your
you
day.
guys.
Thank you.
Thank you.